Okay, synthetic division. Okay, we did synthetic substitution earlier, and it is the same process. So you'll hear me talk about the drop mama concept. Now, all that's going to change is what you read or how you read the results. So instead of saying, all right, X is this number to put over in that box, what you'll have is X minus some number. Now it's X minus K. K is the number that you're going to plug in. So I'm going to put in a positive 1 right there. I've got my coefficients that I need to make sure I list out. Of course, it's got to be in standard form first. And from there, I'm going to drop the first one, and then multiply and add, multiply, add, multiply, add. Now, before there, that would be my answer in synthetic substitution. But in synthetic division, how you read your answers would be these are coefficients of polynomial that decreased by 1 degree. So what do I mean by 1 degree? Well, if I started off with a cubic, I'm going to end up with a quadratic. Well, that's 1 x squared 0x minus 2 and a plus 6 over x minus 1. Now I got that x minus 1 because I'm dividing by x minus 1. You don't really need the 0x squared. That's just how I'm reading my results. So x to the second, x constant, and my remainder. Okay. There's synthetic division. Same exact process. So here it's supposed to be x minus k, so I need to go x minus a negative 2. So the number that I'm going and putting in there is minus 2. At coefficients of 3, negative 2, 5, negative 1. Drop the first one. And then keep on multiplying those by your negative 2. So negative 6. Add negative 8. Multiply. I got positive 16. 21, multiply by negative 2, and get negative 42, so negative 43. Now, again, this is a cubic, so now this would be 3x to the second, 1 smaller than what we started with, minus 8x plus 21 and minus 43 over whatever you divided by, and that was x plus 2. Now, if you're thinking, why the heck didn't we do this instead of polynomial line division? Well, the answer is this only works when it is x minus 2. So it only works for a linear that we're dividing by. Okay, now, factor theorem. What the factor theorem says, and there's my 4 that I'm going to put in my box up here. I'll get my coefficients, is that if I get this synthetic division to work out so that the last number is going to be 0, that means that there is no remainder. Okay? Sometimes it's called the remainder theorem. Okay, if that's true, that means that x minus 4 was a factor of this original cubic, this 2x to the third minus 7x squared minus x minus 12. What do I mean by factor? Well, this 2 is a coefficient for 2x squared plus x plus 3. So this is one factor, and so is x minus 4. So if I were to go through and multiply that out, I would get back to this as my original equation. So x minus 4 is a factor of the original polynomial, that cubic that we were using. Okay. So what I can do is use this factor theorem, this idea, to factor a polynomial completely. Like, for example, The only cubic patterns we've got are the sum and difference of two cubes. But if I can do synthetic division, 2, 3, -3, and -2, and again, make sure it goes from the third power to the second power to the first power to a constant, okay? And that they're in standard form. So 2 times -2, or sorry, 2 here, got -4. 1, 3, 0, 0, and -2. Oh, sorry. For some reason I had those. -2 times that should be +2. That should be a -1, and that should be a +2. There's my 0. My bad, guys. So then I'm left with 2x to the second minus x minus 1. Okay. Now, I know that this is one of my factors because this last number here, maybe I'll clean that up. Get my mistake out of there. But that should be 2, -1, 2, and 0. Because that was 0, that means that x plus 2 is a factor. And then I can look into factoring this some more. So 2x and x. Now I need to get to -1, so I know that 1's plus, 1's minus. I might have these in the wrong spot, I don't know, but I'll put a 1 and a 1 there. Okay, foil that real quick. 2x times 1, -1 is -2. That's +1, that adds up to be -1. Okay, I'm good. X plus 2 is my third factor. And there you go. I use the factor theorem to factor that polynomial completely. And that is synthetic division. Now, I'm going to put one down, and I don't know if it will actually work out. I just want to make sure that we're on the right page. But let's say I've got 4x to the third, and then it goes plus 2x plus 1. And I want to divide that polynomial by x minus 2. Okay. 4, 0, 2, 1. If you're wondering why the 0, because it went from, let's get that back, 4x to the third, and then it went to x to the first. I need to put a 0x squared in that place. So 8, 16, 18, times 2 would be 36. Okay, so 37. So it would be 4x to the second plus 8x plus 18 plus 37 over x minus 2. My remainder doesn't always need to be 0. It's just really nice if it is. It means it's a factor. But again, make sure that you put that 0 in its place to kind of hold that spot.